Okay, I'm going to try doing this forces. One quick little thing, I don't have my stylus. I've left it at school, so I'm going to just use my finger as a pen today. So we'll see how that works, okay? So I just want to set up a simple little demonstration problem or sample problem for you to use to help you in your setting up of your understanding of forces. So let's do just a simple setup where we have a mass sitting at rest on a table and a piece of twine attached to it, and that goes over a pulley and then is hanging down and is such that it has another mass. We'll call this one M2 and this one M1. So pretty simple setup. So simple case here is that the mass M2 is released. If someone's holding it, for instance, and it's released, and then it pulls with a downward force on the piece of string, and the string then, because of the pulley, changes the direction of the force, and that causes M1 to accelerate. So some simple concepts, but we can also apply a lot of basic physics to this and learn a lot. First thing we want to note is that these are connected objects. So connected objects, no matter how many connected objects you have, if one is accelerating in general, then unless there happens to be slack in the string or something like that. But if you're accelerating M2, then M1 would be accelerating at the same rate. So that's our setup, and let's see how we do with trying to find. Let's just say that we wanted to find the acceleration. So we want to find the acceleration of the system. And so I'm going to set it up with no numbers, and we'll just see how it works. So we're going to have friction present. So when we get over to the next page, we're going to do a free body diagram for M1 and M2. So let this be M1's, and like again, I'm not able to make a nice little dot there, but it works. So this is M1, and we know that we have M1G, and we have force normal, and we have force tension, and then we also have, since I said friction is present, we have a force of friction. And let's just say that this force of friction, because of the magnitude of the vector, is less than force tension, indicating that we could have an accelerated system. So then we have that's M1 on the left, and then M2 right here. So M2 is hanging from the piece of string. It's not touching the table. It's just hanging downward. So we have M2G, and we have force tension. So as you notice, I have force tension going to the right on M1 and upward on M2. And that's because the pulley is merely changing the direction of that force. And that's its purpose. Okay, so we need to start writing equations of motion. So let's write equations of motion for M1. So we'll write them right underneath it. So let's look at the summation of forces along the x. Well, that would be, I'm going to read everything I see. I'm going to choose Ft to be positive in this case. And as I told you, like for Ff, if you were king of the world, you could choose whichever one you want. But it's logical to choose Ff to be negative, force of friction. So force of tension minus Ff equal M1A. Notice I said that was M1 because those were the forces acting on M1, so they're going to cause M1 to possibly accelerate. Summation of forces along the y would equal, everything I see there, I see Fn minus M1G, which equals, and we've talked many times about this, we know that would also equal M2A, but we know it's not going to accelerate in that, so we're going to set that equal to 0. So it's an equilibrium along the y-axis. Now, I'm going to draw the summation of forces for M2 above it. So summation of forces along the x equal 0, and actually I'm going to draw it right through it. Summation of forces along the y. Again, I don't have a pencil, so or whatever you call it. Stylus. That's it. Although even when I write with it, it's not very stylish. Okay, and that's just going to have to go to the next page. This guy right here is going to have to go to the next page. You're just going to have to live with me. All right. Summation of forces along the y for M. This is for M2. equals M2G minus FT equal M2A. Okay? Now, notice what I did here. If we go back a page, notice that I chose FT to be positive on M1, and therefore, since FT on M2 is pulling in the opposite direction, it has to be negative over here. So now we've got a setup, and we've got, and we know that in this equation, and in the summation of f of x on the other equation for M1, we know that that was, if I'm not mistaken, ft minus ff equal M1a. So think about this. If you, let me see if I can remember how to erase. Is that it? Yeah, there's my eraser. Okay, so if I take this equation right here and I add it to this equation down here, so let's just add them in place where they are. So if we add everything together, notice that I'll put it in a highlighter, that if this F and this F are opposite because they're the same piece of string, so the tension would be the same throughout, so they cancel out. So now we're left with, so we're adding them, so let's make an addition line down there, and let's go back to pen, and we're going to have M2G minus FF, I'm just carrying everything down on the left side of the equal sign, and then I'm going to factor out A, because remember what I said at the start of this example problem, that the A is the same since they're connected. So we're going to have M1 plus M2 times A. Okay, you may not have known it, but I just had to take a break to answer a phone call from my mom. Oh, moms love to call you in the future, and you don't have to pick up all the time, you know, when you're like my age, okay, just so you know, okay, but you still love them, but anyway, they're mom. Alright, so where are we? M2G minus FF equal M1 plus M2 times A. Why did I just add M1 and M2 together just like that, you know, without worrying about them being vector quantities or anything like that? Because they're scalar. Mass is scalar, so you can just add them together. That's what's nice about scalar quantities. You can just add them together. So this really concludes the example, because think about it. What did I say I wanted to find? I wanted to find a solution for A. All I'd have to do now is divide both sides by M1 plus M2, and I'd end up with M2G minus FF over M1 plus M2. Quick note, for you, just to refresh your memory on algebra, you cannot factor out that, or cancel out that M2, because it's being added in the denominator, so you can't cancel it out with M2G. It needs to stay in there, okay? All right, so that would be A. So give it a shot, see what you think, and we'll look at it tomorrow. It should help you with starting to answer questions tomorrow on, I think it's 2.5 if I'm not mistaken. All right? Okay.